Mukundi, what answer do we get when we multiply these two exponents? You can unmute yourself and then talk because I can't hear you. So if you want to say something, unmute yourself and then talk.
2 to the exponent 6.
Okay, yes. Let me clarify this just now. Oh, I thought she's still joining. Okay, so now for this question, you check if indeed the bases are the same. So the base in this case is 2, and then the base on the other exponents is 2. Therefore, we're going to have a base of 2. This rule, it says that if bases are the same, we add the exponents, of which we're going to add 2 and 3. So 2 and 3, it gives us an answer of what? 5. So it's going to be 2 to the power of 5. So we applied the first rule here. We applied this rule. 2 to the power 2 multiplied by 2 to the power 3, it gives an answer of 2 to the power 5. Because we added 2 and 3, which gives us a 5. Are we all together on that first question? Okay, now let me give you another question to try. So let's say we are having a question of 4 multiplied by 2 to the power of 3. What do you think will be the answer for this one? How do you think we can find the answer of that question? What do you think will be the answer for that question? Don't forget to unmute yourself, because I can't hear you. Rufuno, what do you think will be the answer for this question? 4 multiplied by 2 to the power 3. What will be the answer of that question?
Number.
Oh, you are back. Okay. We're still under the first exponential rule here. So we did the first question, we got 2 to the power 5. So I'm now asking, how do you think we can attend to this question here? Wherein we're multiplying 4 and 2 to the power 3.
We are doing the one for 4 multiplied by 2 to the power 3.
Yes. How do you think we can do this question using the first rule, first exponential rule, a to the power m and a to the power n? How can we attend to this question using this rule? Okay, let me give you clarity. So the very first thing you need to do here is to make sure that the bases are the same for this term and also for that term. So if you see on this term, we're having a base of 2, and then on the first one, we're having a base of 4. Therefore, we need to attend to this base of 4 so that we can write it in terms of the base of 2. So 4, we can write it as 2 to the power of 2 so that we now have the same base with the second term there. So we're going to have 2 to the power 2 multiplied by 2 to the power of 3. Therefore, we are now having 2 terms with the same base. And if they're having the same base, we can then apply the first rule I introduced there, wherein if bases are the same, we add the exponent. So we're going to have 2 plus 3, of which is going to be 2 to the power 5. That is how you attend to these questions if we are using the exponential rule. So now is the first exponential rule. Now let me quickly go to the second exponential rule, which you must take note of and which is very, very important. So is a rule which says that if a base A is having two exponents, the first exponent is m and the second exponent is n. So now the rule tells us that you have to multiply both exponents. If a is having two exponents, therefore you need to apply both exponents. For example, let me use this as an example. Let's say we have 2 to the power of 2, but now instead of having just one exponent, you then have the second exponent like that. So in this situation, if we are applying this rule, exponential rule, which is under algebra, you then have to multiply the two exponents by using this rule. You're going to have 2 multiplied by 3, which will give you 2 to the power of 6. Do you see how we attend to these questions? Are we all together up to here? I would want to hear if you understood what I explained just now up to here.
I understand.
Okay, no, it's okay. Let me give another question which you must try as an example by using the same rule. So let's say we have 4 to the power of 7 all to the power of 3. How do you think we can simplify this kind of question to the simplest form? How can we simplify this question to the simplest form?
We write 4 to the power of 7 times 3.
So it's 4 to the power of 7 multiplied by 3, of which is going to be 4 to the power of 21. So, but you can then simplify further because you can see this is not in the simplest form, or wherein 4 you can change it to be 2 to the power of 2 and then to the power of 21. So this is the same as 2 to the power of 21 multiplied by 2, which gives us 2 to the power of 42. So now these are the kind of rules which you must take note at all times. You will see where this is leading us because we are going to use this under the algebra or the algebraic expressions. We're going to use these rules which I'm explaining to you just now. So now the third rule of which you must take note of is when we have division like this. So let's say a term with the terms with same basis but different exponents. How do we attend to such kind of questions if we're having a fraction form? So in this case, you will need to subtract the exponents like this. So the exponent of the numerator minus the exponents of the denominator. That will give you a new term which we'll be looking for in that case. Okay, let me give you an example so that you can see how we attend to these questions. And then after this, you will then have to try the second one. So we're having 4 to the power of 2 and 2 to the power of 3. Then how can we solve these questions? Now, what you will need to do here is to make sure that the bases are the same, because you can see if bases are not the same, we cannot apply this rule. So we can make the bases to be the same by changing 4 to be in terms of 2 to the power 2. So if we change 4 to be 2 to the power of 2, we're going to have 2 to the power 2 and all to the power of 2 divided by 2 to the power of 3. Now, on this one, can you tell me which rule are we going to use to deal with the numerator there? Because you can see the numerator is having 2 exponents.
We'll use the second rule.
Okay. The second rule, yes, we're going to use the second rule, which talks about the 2 exponents. So of which, if you apply it, you're going to get 2 to the power of 4, all divided by 2 to the power of 3. So now we are having a situation wherein we have bases with the different exponents, and these are in fraction form. So we need to apply the rule I introduced to you just now. It's the one which attends to this kind of expressions, of which you can write as 2 to the power of 4, the exponent of the numerator, minus the exponent of the denominator, which this will give you 2 to the power of 1, which is the same as 2. Do you see how we attend to these kind of exponential expressions?
Yes.
Yes. Very, very important for you to know how you deal with this. You will see when we go to algebra, of which I'm going to cover with you tomorrow. I'm going to cover a full topic under algebra, of which will require us to apply these rules. Now, let me go to a very important rule, but a very simple one. Is there anyone who knows what this will be equal to? Any number to the power 0 is equal to what?
Any number to the power 0 equals to 0.
Verify that with your calculator. Do you have a calculator with
No,
you?
it's one. It's one.
It's equal to what?
It's a math error.
Verify with, let's just pick a 2 as a number and then to the power 0. If you put this into your calculator, what do you get?
It's one.
So you must remember this rule at all times because you may come across these kind of expressions for you to deal with. Any number, it doesn't matter how big it is. As long as it's having an exponent of 0, that number is going to be equal to 1. Let me give an example of that which I've said now. So let's say we have 2 to the power of 8 divided by 4 to the power of 4. So now let's apply the exponential rule. I know when you put this into your calculator, you're going to get the answer. But here, let's not use calculator. You must be able to simplify without using any calculator. So let's deal with this question. So the numerator, we can leave it as it is, but the denominator, we must make sure is having the base of a 2. Can anyone tell me how can we make the base to have the denominator to have the base of 2? Because if it's having the base of 2, we can then be able to apply the rules I've given you. How can we write this with the base of 2?
We'll write it as 2 to the power 2.
Yes, it's going to be 2 to the power of 2. But again, you must remember that it's having an exponent of what? Of 4.
Of 4.
Yes, so it's 2 to the power 2 and then to the power of 4, of which in this case, you can then apply rule number 2 to deal with the denominator. So if you apply rule number 2, 2 multiplied by 2 is going to give you an answer of what? Of 8. Do you see that?
Yes.
But now, because we're having a fraction, you then have to apply this rule that we have up there. We're going to have 2 to the power of 8 minus 8, which is
Equal to
the power
2 to the power of 0 equals to 1.
We now know 2 to the power 0 gives you an answer of 1. You see that we use this rule number 4 to get an answer of 1. We use the rule number 4. Are we all together up to here?
Yes.
Okay. Let me not cover much about this algebra because I'm gonna give you everything about this chapter tomorrow. Now I was just taking you through we started with the number system, and then now I took you through the exponential rules, of which we're going to use to deal with the questions under algebra tomorrow. So our lesson tomorrow is going to focus on the algebra. Come with, yes.
We have homework as.
Oh, okay. And your homework is under what?
It's under the, let me check. It's the things that I don't understand. The rest of the things I understand, but I don't understand this thing.
The topic.
Huh? Yes, I sent you the topic on WhatsApp.
Oh, this one's you sent. Okay.
Yes.
And the homework is question number what?
It's it's those pages. Page 10, it's number 1, A, B, C, D, and E.
Exercise
Exercise 1.6. And page 11, number 1 and 2, exercise 1.7.
Okay. Let me start with this one on page. Exercise 1.6.
10.
Okay.
Yes.
Okay.
Nipa baby.
Nirmini?
Riko nipa.
Okay.
That's Viva.
Let me quickly do your homework now. Before we leave.
Yeah.
Let me do some of the questions for homework. But if time not allow, we're gonna finish other ones tomorrow because I'm meeting you again tomorrow. So we'll finish up those questions tomorrow. So let's start with this one on it's exercise 1.6, question number 1A. So we have X, we have 3, 5, 7, 9, 11. Y we have 6, 10, 14, 18, and 22. Okay, so now
Adi.
oh, is she?
Yeah. Adi.
Oh, Adish is connected now. Hello?
Adi.
Okay.
Okay.
Madam Bowie. Uko join Adi.
Uko Jabu.
Yeah, argo mulinda la oja bugu te.
Okay.
The video call.
That. Oh, okay. Yeah, we are now doing the homework you are given from school. So I'll start with questions under exercise 1.6. So we have question number 1A. We are doing question number 1A under exercise 1.6. So let me read the question so that you can identify the homework we are doing now. It says, are you hearing me?
Yes, we can hear you.
Okay. So it says in each of the following, write down whether the tables provide examples of numbers in direct proportion, inverse proportion, or either. So we must, we have 3 options to choose from. The first one is direct proportion. And then the second one is inverse proportion. And then the last one is either. It's neither of these. So now let's choose from this table that we have here. So you can see we are given a table with values of X and a table and again a row with values of Y. So the values of X, they are increasing in the same rate. So we're having 3, 5, 7, 9, 11. Can any one of you tell me what will be the next number after 11 if we are to find the next number in that case?
13.
It's going to be, yes, definitely. So in other words, we can be able to see the sequence of the numbers of X we are given here. So similar with what we have on Y. So for the Y, we're having 6, 10, 14, 18, 22. What number can we have after 22 if we're following the same pattern?
24.
We are 24. So in other words, we can be able to see the pattern from this table. Now, let's go straight to what the question requires us to find. We want to determine if on this table we have a direct proportion, we have inverse proportion, or we have neither. So now, let's first focus on the direct proportion. What do you remember about the definition for direct proportion?
They have a constant quotient.
They have this constant quotient, coefficient. And then the second, because you have to mention 2 properties for this. The first is that it has a constant coefficient. And then the second,
As one quantity increases, so will the other.
very true, very, very true. So we have to check those 2 things. So now let's first determine the one for the first, for the constant coefficient, of which I believe you have seen that these numbers, they are increasing with a quantity of what? Of 2. Do you all see that?
Yes.
So the difference between 3 and 5 is 2. The difference between 5 and 7 is 2, up to so on. Therefore, it achieves this first condition for the direct proportion. So similar is on the variable y. So you can see if you take the difference between 10 and 6, it's going to be the same as the difference between 14 and 10, 18 and 14, up to so on. So it has a constant coefficient. And then now the second part of that definition is what is critical. So you must check what happens for y when x increases or when x decreases. So now you can see the x in this case is increasing, right? So when x increases, when x increases, what is happening on the y? Is it increasing or is decreasing?
And also increasing.
It's also increasing, definitely. So, and now if x is increasing and y is increasing, therefore that achieves the definition of direct proportion. So now let me also explain the inverse proportion, because these two they are related. Again, for the inverse proportion, the first condition is that it must have a constant. It must have a constant coefficient. And then the second is that it must, when x is increasing, then the y must be what? Must be decreasing. Are we all together on that? So when x is increasing for inverse proportion, the y must be what? Must be. So now tell me the answer for the first question. The first question is this one. Is it direct or inverse proportion for this first question?
Proportion.
Is it direct or inverse?
Direct proportion.
Is direct proportion, yes. And I've given you reasons why we say this is direct proportion. Okay, then now let's quickly go to the second one, and then you tell me what we have for table number 2. So we are given x with values 2, 4, 6, 8, and 24. And then y is 7, 36, 18, 12, 9, and 3. Okay, let's check this one. Let's check if this table have direct proportion, indirect proportion, or neither. So let's first check for the x. Does it have a constant quotient? Does it have a constant quotient in this case? You check the difference now. So the difference between 2 and 4 is 2, right? The difference between 4 and 6 is 2. The difference between 6 and 8 is 2. What is the difference between 8 and 24?
16.
16, and that violated the condition for the direct and indirect proportion, because now it's no longer having the constant quotient. Are we all together?
Yes.
Yeah, I can't hear anything.
Can you hear me now? Can you hear me now? Okay. Yes. Now tell me what would be the answer for this table that we have here? Is it going to be direct proportion, indirect proportion, or neither?
Neither.
It's going to be neither. What's the reason for this to be neither?
Because it's not.
Because x is decreasing, and then that y, no, it's not.
Yes, it's not, it's neither. The answer is neither, but I would want to know why we say it's neither for this case. It's neither because it does not have the what? The constant quotient. Yes, that's the reason. This will be neither because it does not have the constant quotient. Are you all with me?
Yes.
Yes. So you must understand these tables. Let me give you the third table, which is from the homework you are given from school. So we have covered A and C. And now let's go to the next question. So this is the next question which I'm going to write here. So it's number C. We are having a table with X and Y. So under X, we have 15, 45, 135, 210, and 270. And then for Y, we have 5, 15, 45, 70, and 90. Do you all see the table I wrote just now? Do you see the table I wrote just now?
Yes.
Okay, so now let's test the conditions for the direct, inverse, and then neither proportion. The very first thing which we need to do is to check the constant quotient or the constant coefficient. So now the constant quotient in this case you can get by checking the difference between these values we have here. So if we subtract 45 and 15, what do we get?
3. We subtract what?
45 and 15.
We get 30.
We are going to get 8 in this case.
Okay.
And then if we subtract 45 and 135, 135 minus 45,
Negative 90.
you subtract from here, from the third to the
Oh,
second. So it's going to be positive 9, eh?
yes.
And then when we subtract these two values, what we obtain?
We get 75.
75. And then for the last one,
Uh,
60, right?
yes.
Yeah, exactly. Then now, that simply tells us that we don't have constant quotient. Why we don't have constant quotient? Because these values are what? They are different. Are we all together on that?
Yes.
So with that
Yes.
information, we can then go to the conclusion. What will be the conclusion for question number C?
They are neither direct proportion, inverse proportion.
Very true. It's neither direct or indirect, inverse proportion. So now let's quickly go to the last question on this page. So the other questions we're gonna finish them tomorrow. Let's attend to this as our last question for the day. So we're having 100, 80, 60, 20, and 40. And then for Y, we have 24, 30, 40, 120.
60.
Yes. Now, without explaining any further, can you tell me if this satisfies the condition for the direct proportion, inverse proportion, or neither?
Which one is that one? I can't find it here.
Question number D. This question number D under exercise 1.6.
I can't see it.
No, it's inverse.
Is it?
Inverse proportion.
Okay.
Inverse proportion.
And what's the reason for that to be inverse proportion?
The percentage
The X is
and they have similar differences.
Okay. Yes. Nice try. So, but let me explain this to you. Why we say this is inverse. Let's check the X here. The difference for X throughout. What is the difference for X on these values we are given here? Fortunately, they have the same difference. What is the difference in that case?
20.
It's negative. It's negative 20. Is it we supposed to subtract from negative? So now, this X, is it increasing or decreasing? This X we're given here is decreasing, okay? And now, I believe we can all see that the X that is given there is what? Is decreasing. Now, let's go to Y. So for the Y, we don't have to check for the pattern. We don't have to check if it is constant, constant coefficient in that case. So we only have to check if these values were given here, they are increasing or decreasing. Are the values of Y increasing or decreasing?
increasing.
They are increasing, yes, definitely. So, and if you go back to the definition, you will see that if x is decreasing and y is increasing, therefore that condition is what is called the inverse proportion. Even though it's other way around, for example, let's say x is increasing and y is decreasing, that condition is under what is called the inverse proportion. So that's why in this case we're saying it's inverse proportion, because x is decreasing while y is what? It's increasing. Are you all clear with the
Yes,
homework? Yes. Are you all clear with this homework we have covered under exercise 1.6?
Yes.
Is there anyone who's having a question with regard to what we have covered up to so far?
No.
You are all fine, eh?
Yes.
Okay. For today, let's end here. We have covered a lot of things. For some of you who joined our lessons a bit late today, I'm going to send you the recording so that you will get everything
Okay.
we have covered from the start. So otherwise, for today, let's end here. Tomorrow, we're going to cover algebra together with some of the questions I did not do with you today under the homework you're given from school. Ne?
Yes.
Yeah, so that's it for today. We're gonna meet tomorrow. Same time. Okay, goodbye. Ne?
Bye.
Bye.